Hello guys, page 7 of the packet. I know we started number 10. Pause the video if you need to check this work and you haven't in class, where f is increasing, decreasing, closed interval, local min. I use my calculator to find the y coordinate because I'm going to take this point and plot it on my graph. Concave down, CD, concave up. And then here's my inflection point, and again I found the y coordinate. Go ahead and plot these. This local, where is that local min? This local min, plot that, and plot the inflection point as well, if you haven't already. And this is about here, that inflection point. So sorry, the local min, and the inflection point is about here. So I'm just going to find a few more things that are not calculus related about my function y. I'm not sure if we found the x-intercept in class because the x-intercept is the origin. This is the only time that x times e to the x is going to equal 0. It's when x equals 0. So it's the only x-intercept. This is the only time my graph is going to cross the x-axis, only at that point. This sign chart tells me my f is decreasing, right? F is decreasing until it hits -1. So here's -1. My f is going to, sorry, let's try this again. Here's -1. My f is going to decrease, hit this local min, hit this valley, and then go through the x-intercept, and then after it hits the local min, my f is going to increase. Now I can't start up here. Look, if I start up here, then I have another x-intercept, which is not what we want. So you must start below the x-axis. You can't touch the x-axis until you reach that x-intercept. So we're going to go through this point. We're going to decrease, hit the local min, and continue. This tells me concavity because that's the inflection point. I want to make sure that my graph of f is concave down. So let me remind you, concave decreasing and concave down. Here, this is concave up, and I'm not going to draw it because it's still decreasing. So going to decrease, but concave down. This is me drawing something that's concave down. Exaggerate the concavity without like creating a cusp here. This is concave down, and now it's going to open concave up, and that you can tell is concave up. Here's the local min it hits, and then we're going to try to do this nice and smooth, and here's the x-intercept. Again, it's sort of like hugs. It's so hard to tell the concavity here. It's more exaggerated right here, right? I didn't want to do this. Like this would be wrong. Like that would be wrong, because the concavity is not concave down. So this is the best interpretation of it being concave down. That's the best interpretation. Concave down, concave up, and it's going to stay concave up forever and ever because after -2, it's the second derivative is positive, and this is what the graph of number 10 looks like. All right, I hope that helped.